All right, this is Algebra 1. We are on, today's date is Monday, December 9th, so 12/9. Today's lesson is 5-6, number of solutions. We're just doing the graphical version today. Tomorrow we're doing the algebraic version. Before we get too involved in the notes, let's take a look at what I had for the warm-up. So we don't have any tests this unit, just the final, and we're going to start reviewing for the final on Thursday, so that means our last day of new material is on Wednesday. I want you to be thinking about these questions. When you're graphing an equation, what does that line represent? Also, when you graph a system of equations, what does that intersection of those lines represent? And then if you had a system of linear equations, you can have no solutions and infinite solutions. So what do you think those might look like? And those are the questions you don't have to necessarily answer for number 3. Definitely 1 and 2, you should have some sort of idea. But let's go ahead and get started with the notes. So our objective today is to graph equations in slope-intercept form and standard form to determine the number of solutions. So we're just all about today's number of solutions. Of course, that's because of the title. All right, so graphing review. So slope-intercept form. What is the general form for slope-intercept form? So I urge you to pause the video and try writing down the general equation to both of these now. All right, so I'm unpausing the video, or you're unpausing the video, and this is going to be y is equal to mx plus b, and standard form is ax plus by is equal to c, and remember a, b, and c are all integers, that is whole numbers. So an example of something in slope-intercept form, you could have y is equal to 1/3 x minus 2, and something in standard form, you need to make sure that the number on the right, if it's like 12 or something, both a and b are typically divisible by 12. So one of the factors of 12 is 3, so I can do 3x, and then I could do maybe -6, or it can even be -4. It doesn't really matter, as long as it's usually divisible by that number. All right, so our steps for graphing slope-intercept form, we first graph this y-intercept. So we graph -2 on the y-axis. So that's going to be 0, comma, whatever this number is, and we usually call that b, right? So 0, comma, b is always the y-intercept. And then you're going to use the slope to find the second point. And again, remember that the slope is the change in y divided by the change in x. So the bottom number represents how much to go, usually right. And depending on if the top number is positive or negative, that will be how much up or down to go. For standard form, it's a little bit easier. You just find the x and y intercepts and graph the x and y intercepts. So x-intercept is where y is equal to 0, so I would basically cancel out that term. And the y-intercept is where x is equal to 0, so I cancel out that term and then solve. Just be careful of negatives when you're doing that. All right, so our first example, usually they're both going to be in standard form, or they're both going to be in slope-intercept form, but I'm mixing them up so you can get some good review. So I need to graph them, and then I'm going to ask you, how many solutions does that system have? And I'm going to do another example, and eventually we're going to come back and review, like, well, what does it mean? So I'm showing you the examples first before I show you the information. It's inductive learning. So here we go. X plus 2y is equal to 4. That looks like it's in standard form because I have ax, something x, and then y, then a y, and then is equal to a number on the right-hand side. So everything looks like it's in standard form. Let's go ahead and find the x and y intercepts. So first I'm going to make x equal to 0 and find the y-intercept. When I make x equal to 0, I'm left with the equation, just 2y is equal to 4. I'm going to divide both sides by 2, and I get the equation over here, y is equal to 2. When I cross out the y to find the x, or the x-intercept, I just get x is equal to 4, so that's pretty straightforward. X is equal to 4. And I'm going to graph those two intercepts. So y is equal to 2 on the y-axis. X is equal to 4. 1, 2, 3, 4. You have to count them since they're not labeled. And those are the 2 points. So I also forgot to say that we need a ruler today. So you might need to pause the video and grab that now. And then, of course, I can go 1, 2, 3, 4 to the left and 2 up. 1, 2, 3, 4 to the left and 2 up. So another point I could add is right here to make it a little bit more precise. And here is our line. Alright, so that's one line. Again, we need a second line to make it a system. So this is in slope intercept form because it has y equals on the left, y equals on the left, a slope x plus the y-intercept, so plus that b. Everything looks like it's in slope intercept form. That means our steps are to first graph the y-intercept, that is this 1 over here, this b is the intercept, so I'm going to come up 1 on the y-axis. There's this, there's the y-intercept. And then I'm going to use the slope as my second step to find a second point. So remember the bottom number tells you how much right to go. So I'm going to go 2 right. And this negative I always associate with the top, so I'm going to go 1 down. So 2 right, 1, 2, I'm currently at this point, and then go 1 down. So this is my official point down here. And I'm going to go 2, I guess I can make these opposites instead of up, or sorry, 1 down, 2 right, I can go 1 up, 2 left. So 2 left, 1 up, 2 left, 1 up. And it looks like those are not going to ever intersect. Let's go ahead and graph this line. Interesting. So normally, if we're looking for the solution, it's wherever those lines intersect. But these lines never intersect. So what I'm trying to get at is we don't have any solutions. Because again, if I ever have some sort of graph where they intersect, I say, oh yeah, that's the solution right there. That's the solution. But if they never cross, and it looks like these don't because they have the same slope in this case, they will never have any intersection and therefore no solution. I'm belaboring the point, but the answer is no solutions. And I forget if on Khan Academy they say no solutions or 0 solutions. It's one of those two. I guess I can check the back. I guess they might call it 0 solutions. Let's try example 2. So this one, I urge you to pause the video and try it out on your own. You have a good example here to help you out. But you can play the video in bits and pieces to just give you hints. That'll be the best way to go about doing number 2. Alright, so you've unpaused the video, and this first one again is in standard form. So standard form, I essentially cross out the y at first, so I get 2x is equal to -6. If I divide both sides by 2, I get x is equal to -3. So let's write that out off to the side. I can actually write it, yeah, right here is fine. X is equal to -3. What happens if I cross off the x? If I substitute 0 in for x, I get -2y is equal to -6. And I have to divide both sides by -2, divide by -2. And I get those -2's canceling out, and y is equal to +3. So I'll come over here, y is equal to +3. Let's go ahead and graph those. Y equal to +3, there it is, x equals -3. Alright, I have those 2 points, and I make a line. Oh, bless you, guy. Alright, so now we're on to the second line of the second equation. Again, it's in slope-intercept form, so the y-intercept is -1. Coming down here to -1, perfect. The slope is -3, which is the same thing as -3 over 1, which means I go 1 right, and this is a -3, so 3 down. So go 1 right, 3 down. I can do the opposite of that as well. I can go 3 up and 1 left. So 1 left, 3 up, 1, 2, 3. And again, 1 left, 1, 2, 3 up. And how's it going, Riley? It looks like this system of equations has one solution because it crosses at one spot. And that's what we're used to, right? We've been seeing that over and over again. So you can kind of circle and say, oh, look, that's the solution right there. It's -1, 2. But how many solutions does it have? One solution. Okay, so now we get to do a bit of analysis on all the math that we just did. So a solution to an equation, we've defined it before, I think it was like lesson 1, but a solution to equation is every single point on the line. So I'm just going to say every or each, it doesn't matter what you use. Every point on the line, aka the line. The line is the solution. So when I came back and graphed this yellow line, that was every single point, this point, this point. There's an infinite number of points on this line. Every single one of those points satisfied that equation. So every single coordinate pair was, quote unquote, a solution to this one equation, which means there are an infinite number of solutions to that one equation. But once I turn it into a system, a solution to a system of equations, now I have two lines. A solution has to be both on this line, this yellow line, and on the blue line, which means a solution to the system of equations is the intersection, or the point. It's usually the point, this point right here, where the equations cross each other or where they intersect each other. I'm going to use the word intersect, where the equations intersect. Okay, so let's go ahead and see what are graphs of, what are they going to look like when I have one solution. And it's kind of similar to this one. When it's one solution, they somehow cross, and it doesn't matter how they cross, they just have to cross. So I'm going to do a line like that and a line like that. Boom, they cross. And you can circle, hey look, yes, exactly, one intersection, one solution. We had an equation with 0 solutions already, and that's when they never cross, when they're parallel lines. So you can go ahead and do your best attempt to draw parallel lines. Maybe I can draw them a little bit slower. Oh gosh. And I get parallel lines. Infinite solutions. Take a guess what that would be. How do I get infinite solutions? And I've kind of given you a hint when I talked about if I just have one line, every single point on that line is going to be a solution. So there's an infinite number of solutions on just one line. All right, so an infinite number of solutions, think about this as the same line. I have a blue line and then a yellow line that's exactly on that blue line, because now those two lines touch every single point. They're an infinite number of solutions. All right, so let's take a look at the slopes for each of these. It's kind of interesting to look at the slopes for these two lines first and then talk about this one later. So with the 0 solutions, these two lines have the same exact slope. So I'm just going to say same here. Oh, that's not how you spell same. And look at this one as well. Infinite solutions, these have to have the same slope as well. Okay, let's compare. I'll come back over here to slope, I guess, right? These slopes have to be different. Did you just hit the desk? Okay. And if they're different slopes, that automatically means they're going to be one solution. You don't even have to do the y-intercepts. This y-intercept is only to distinguish, well, if these are both the same, then what's the difference? The difference is the y-intercept. So check it out. If I have 0 solutions, then the y-intercept, one was here, which means there are different y-intercepts. So I can say different here. And if I have infinite solutions, they have the same y-intercept. So that's the way to differentiate between 0 and infinite solutions. If I already have different slopes, I don't really care about the y-intercept, so you can either say don't care, or you can cross off this box. That's all you need. Okay, so why are we doing this table? This table will help you immensely tomorrow when we do a lesson on solution or number of solutions of equations purely with equations. So tomorrow we're doing this without graphing it, and you have to be able to find the slope and the y-intercept of each of these equations, and just judging off of this table, you'll be able to say, oh, okay, I can tell how many solutions there are. All right, I think that's everything. Yep, that's all we have for the notes. Good luck on Khan Academy. Hopefully I'll see you guys tomorrow.